This lesson is on multiplying special case radicals. So special case radicals are radicals where we would be able to easily find the answer. And of course, one of those things is if I have an index and an exponent that are equal, we know that those things will cancel each other out. So the square root of 13, quantity squared, I would take the square root, then I would square it again, and I would end up with whatever's inside, which in this case is 13. Same is going to happen here. My answer would be xy. Same is going to happen here. My answer would be ab. Again, we're just assuming that everything is positive at this point, so we're not going to worry about absolute value signs. Another special case radical would be a square. So if it's a perfect square, remember we had that rule before. If you had a perfect square, you would square the first term, twice the middle term, square the last term. If you don't remember that shortcut, remember that you would then just write it out twice and then FOIL. So radical x times radical x would give me x. Radical x times minus 3 gives me minus 3 radical x. And another minus 3 radical x. And then, of course, my last one would give me plus 9. My simplified form would be x minus 6 radical x plus 9. Now, if I am just using the shortcut, notice what I did. I squared the first term, so if I took radical x and I squared it, that gave me the x squared. Then I took the product of these two, so I took the minus 3 and the radical x, and I doubled it, which is where I got the 6 radical x, and then I squared the last term, which gave me 9. So let's do the same thing here without having to FOIL it out this time. So if I squared the first term, I would get 16. 4 times 4 is 16. Radical x times radical x is x, so I would get 16x. If I multiplied these two values together, I would get 4 radical 2x, but I would double that, so that would give me 8 radical 2x. Notice that other part in the middle, that radicand, did not double. And then for the last one, I would square that, so the square root, or sorry, radical 2 squared would give me 2, and that would be my final answer. This is the difference of squares pattern. This one is fairly straightforward. We'll do the first one the long way. Radical x times radical x gives me x. This gives me minus 4 radical x, and then of course the other middle terms give me plus 4 radical x. And notice what's going to happen here is these are going to cancel, and the last one gives me minus 16. So those cancel out, and I just get x minus 16. So the difference of squares pattern says square the first one, and then put a minus sign in between, and square the last one. So again, notice that's because they have the same values added and subtracted. So if I square the first term, that would give me 4 times 3, which is 12. And if I square the last term, that would give me 5. And then, of course, 12 minus 5 is 7, so that's my final answer. Here is a little bit of practice for you to do on your own, so press pause, do all of the questions, then press play to see how you did. For the first, again, I've got the 4th root and to the 4th power, so very straightforward, they just cancel each other out. For the next, I've got a perfect square. So again, I'm going to square the first term, which gives me an x. I'm going to multiply the two together and double it. So that would give me 3 radical xyz. Doubled would give me 6 radical xyz. And then I'm going to take the last term, and I'm going to square that, so that would give me 9yz. This time I had all pluses because there was a plus here. This one will always be a plus. If this value is a minus, then this value would also be a minus. And for the last one, this is a difference of squares. So I'm going to square the first, which gives me 4xy. And then I'm going to subtract the square of the second. So that would be 3x. And that's all I can do on that question.